Hi, everyone. Welcome to the May 26th meeting of sig-auth. Looks like we have two items on the agenda. First is the CSR duration hint. Do you want to kick this off, Mo?
Yeah, I just put it on the agenda in case anyone had opinions on the name of the field or any of that. I know, Mike, you had requested some other stuff. I honestly don't have a strong opinion on exactly what we call this field, but if folks want a bike shed on the issue or on this call, I'm welcome to listen to whatever folks feel strongly about.
Yeah. Speaking of bike shedding, did you also see the discussion in the SIG release chat around somebody not wanting us to modify already implemented KEPs?
I have not read the details. The idea of writing a new KEP for a field is silly. I will I'll deal with that offline though. I think.
All right.
Oh, Clayton wants bike shed. Do you want to share your bike shedding? You don't like hint?
No, we don't have to do it here, but I don't think hint should be in the API.
Okay.
So it's more of just an API conventions thing. I stumped a couple of other hints historically, and so we don't really have it written down, but I'll take a look at the KEP and try to see if we can drive to conclusion there and get a policy written down. I'm on a naming consistency kick this month.
Okay, cool. Yeah. This is exactly why I brought it up. I figured folks care about the strings we put here. So the implementation is relatively trivial. I just made it the minimum of the two options that you have. So that part's pretty straightforward. Mike, I will address your comments. I just haven't had a chance yet.
Sure, no problem. I would kick the naming to Liget. I think there were 4 alternatives discussed in the PR. So, and any one of those, I'll let Liget decide because he's good at naming stuff. The other thing that I was wondering was, do we need to file a extension to get this into 122?
Yeah, so I was gonna follow up and make an exception request and all that and detail stuff. So yeah, I plan on doing that this week.
Awesome. Well, yeah, I think this is fairly uncontroversial other than the name, which is only medium controversial. So
I see David's on the call. I don't see Jordan, and I see James is on the call. You guys have opinions about certs?
I'm not going to argue on the name.
Okay, good.
Yeah.
It's fine. I just wanted to ask.
So once you figure out what KEP to change, point me at it, and I will complete the review.
Awesome. Thank you.
Cool. Anything else on that topic? That was just a pull of note.
I think the Tahir and friends have the floor for lots of stuff with certs.
All right, let's hear it.
So I basically took the feedback from the last time we presented this. So we're taking a step back and saying, so first, before we talk about any mechanism, however we do this, we should decide whether or not issuing certs to workloads is something that is a good fit for the Kubernetes base project. I think the arguments here, at least as I see them, come down to, there's one that's very important to me, and then there's some around, well, we can simplify other pieces of infrastructure. The primary one is, today, Kubernetes issues access tokens or identity tokens to workloads that run in the cluster, and they are bearer tokens. which means they can be stolen, they can be replayed. You have to be very careful about what you do with them. MTLS is harder to set up, but it's also harder to misuse because you have split your identity into a private key and a public signed certificate, and the private key never leaves your client or server. So that means it obviates most of the concerns around like, oh, your token could be stolen and replayed somewhere. And also any intermediary proxies or even the server you're talking to can't impersonate you without compromising the backing CA. So that's kind of the main point as I see it. And then Mike pointed out to me that there are two sort of ongoing PKI related pain points around aggregated API servers and in-cluster webhook backends. I need to actually go through and actually set up an aggregated API server to make sure, like to see exactly how we could improve that process if there were like commonly available certificates. But I do have some experience with the webhook backends, and it seems like there are some opportunities, like if a pod automatically gets some certificate that the Kube API server knows how to trust, that would make setting up webhook backends have less friction. Obviously, the caveat is there is that we have to teach Kube API server how to trust those issued certificates.
And so in this case, I'm just trying to understand what you're saying. In that case, you're talking about a serving certificate, and previously you were talking about a client certificate. Do I have that right?
Well, there's no distinction there, right?
Yeah, they don't need to be different certificates.
Sometimes.
So that is technically true. I'm going to say that I believe there is a pretty significant distinction between a certificate used to identify a client and a certificate used by a client to ensure that it's talking to the correct server. We have treated those very differently in Cube. And that's why you can set different CA bundles for the different categories of things. So I do believe that they are different.
And they're treated differently outside of Kates as well. I mean, in the larger scope of the world, you don't use, you have to set specific usage in the certificate. And there are rules around how that's handled.
Absolutely, but significantly, those have to do with not identifying identity with how the CA system is set up. The CAs that are in use in public web browsers are not identifying your identity as a client. They're identifying your identity as somebody who is publicly hosting a web server. But because we don't, the reasons that we don't issue client certificates using the public CA list do not apply within a corporate, within an internal CA like the one that we want to put into Kubernetes.
I think I would dispute that the distinction here doesn't matter and that they would or should be signed and authenticated using the same CA. I would not expect that. And I would expect that you would face different issues with trying to create serving certificates and distribute them than you will with a narrow client certificate that is simply giving an alternative way to identify a service account.
So I think I'm predicating what I'm thinking about in terms of not piggybacking on the existing TLS library behavior for verifying the certificates of servers you're connecting to. Instead, I'm presupposing that you want to identify the service account of the backend you're connecting to, and then you have some out-of-band method for deciding whether or not that is the correct service account to be backing what you're connecting to, which I understand is a different model than is commonly deployed.
So
For server auth.
Yeah.
So my perspective is that both of them work together and that you can pick and choose one. Having both doesn't actually create security problems so long as your application picks and chooses one or the other that it's making use of.
Clayton, did you have a comment?
Yeah, well, and it's a slight change, so I don't want to derail the split. I kind of agree with the split, just based on prior art as well. Even though they could be combined, splitting them leads to better semantics, especially if it's all done automatically. It hems us in less in the future. I guess my question would be, we put in like a whole bunch of CSI stuff to enable people to go do things like this. Has that been tested or leveraged? Because in theory, I don't know of anything that would prevent you from demonstrating this today with a local CSI plugin that got the pod's service account and issued client and server service accounts and put them in disk automatically the same way that the service account controller does for secrets.
So we have an example coming. It is held up by Service Mesh Politics right now.
Okay. But you didn't find any blockers in that flow except the blessed nature of a volume name in the Cube API and a convention that other people could depend on?
Yeah, so the convention, I think, is the main thing that seems important to me. Like, just like there's a convention that there is an OpenIDC Connect token available at a certain path within your container file system. It would be nice if there was a convention that you could rely on to discover a cert that asserts your identity.
And certainly, like, this is, so Denise and I argued about this early on in the service account token changes, but like, I felt like one of the original goals with pod identity was to allow you to drop in unidentity. There are trade-offs. Tokens are better in some cases and worse in others. And we at the time agreed that some of the aspects of TLS were better, but we wanted to focus on something that fixed the pragmatic problem. I am certainly strongly in support of the idea of this, even if it might, it's kind of the, could we derive consensus? Is this the right thing for the community? Would everybody benefit? I certainly believe every application would benefit by having a server cert that identified it tied to the pod. The question is does this bring in so much extra complexity that we'll spend the rest of our lives chasing the details of certificate revocation, to the lessons learned during tying web tokens to pod location? Are those transitive? Because most people most of the time do want a server cert, and most people most of the time definitely want a client cert. They just may not use it, but it's a better solution than a token in a number of cases. So I certainly am in favor of it. I just understand the time it will take to drive this out.
Yeah.
What about TLS for aggregated API servers and webhooks? Do we agree or disagree that the current requirements to set that up are either too challenging to do securely, or I don't know. I'm thinking about Gatekeeper, which has a, I think it's like grants itself permission to approve CSRs, and it has just a control loop right inside Gatekeeper to approve its own serving certificate. And then that pattern has been copied out because it's kind of like the zero config, only a zero config mechanism for securing a webhook backend. And it seems like if we want people to extend Kubernetes using these API extensions, we should probably do better as sig-auth.
I was going to ask, so there's a difference between the identity being tied to a pod and the identity being tied to a service and a name and the naming system. The things that make naming really easy are the things tying it to service and DNS, because if you don't, you definitely have to know that the pod is suitable. Like when you talk to a webhook in Cube, you're really, ideally you'd be talking to one of a set of webhooks. And when you start getting to that level of detail, if you want to verify the identity, you then have to verify that that pod is supposed to be in that set, which starts bringing in extra complexity. And like David's point about service signer cert is exactly where I'm going, which is saying that something is part of a set is something that Cube does. This is saying it's a pod. Those are not the same thing. And for webhooks and aggregated APIs, if you're on cluster, you do kind of want to say this name. I trust Cube to do the connection between the name and the identity. But if you just do it on pod identity, that's not really enough. And then if we were to make an argument, oh, well, then we'll just add something to the pod that says it's part of this service, that gets into territory that we had historically said was very fraught. Like when we added it for stateful sets, I still think it's coupling a pod directly to a service is a little weird. Coupling it to the default one is fine. But then if you want to couple to any of the other services, you'd have to come up with some new mechanism for naming. So that's where I get a little weird about.
So
What about coupling a webhook to a service account?
Exactly, yeah.
But again, that a service account can be a singular. We have never grouped things by service account other than security. So like the question is a service account tied to a service? And services and pods are orthogonal. Pods and service accounts have a parent-child relationship. I can only be a member of one service account as a pod. And while I think there is a use case that I would like to say, yeah, the simplest one-to-one mapping is this is a pod, it's in a service, and it's in a service account. I am a little weirded out by that relationship not being flexible.
Yeah, the only scenario where that would bite you is if you were trying to migrate a webhook backend from one service account to another in the same namespace, which seems like a fairly small.
Well, so
well, no.
I want to say you're talking about creating a new way to verify a server, and what I'm going to say is that for the two cases you brought up, aggregated API servers and meshing webhooks, we can actually use the normal server TLS verification, the one that's been around since before we were born, and it is not hard to build something that sets that up. There are multiple demonstrated solutions for doing it that mean that you rely on nothing but an annotation on a service and an annotation on your API service. And it handles.
But that's just another way of binding a pod to a service. You're just like, you're saying that.
I'm saying
No.
if the pod author opts into doing it,
yeah,
and then we can leverage that to use standard TLS, that seems easier for the rest of the world to understand. I'm not saying that this feature might not have a place somewhere else, but I wouldn't claim that it is the best solution for API services and Micah's old API services and admission webhooks.
Yeah, I was only gonna, so maybe to go back. So the client part, I don't think is disputable. Client certs have a significant advantage over tokens, and they don't disclose security when they're in contact with something else. But we don't necessarily have as clear of a use case in Cube for that, unless we can come up with one. On the serving side for TLS webhook or for webhooks and cert or webhooks and aggregated API servers that are running on the platform, I still feel the connection is to the service, not the service account. And then that's, I think, what I would probably worry about going too far on this, unless we can come up with an approach that does not tie identity, because like David, what you're saying is like the set identity is from a service account, but what we really want to do is verify that the server we are talking to is in the set that we expect it to be, and that gets a little like that doesn't I don't like that mapping being through the service account. I think that's really through a service. That's what a service is a set of pods.
I mean, within my kubectls proposal, the set of services that your pod matches are used as host names. I don't actually like that. I don't think that you should be using that as auth. I think that Google has internally been verifying the service that you are connecting to by its service account name for longer than I was there. And I was there 10 years ago. I think this is the right answer, that you need to be, as a corporation, you need to be thinking about who it is you are trying to connect to, not names that are arbitrarily assigned to service, but identities.
And that's a really strong argument. If that shows up in the CAP, and I haven't read it, that's fine. That kind of history is like, that's an argument that I think is like an argument from authority, and there's a relevant authority there. Like, if we can come up with a strong enough argument that that applies to everybody else, I think that's an argument we could potentially play out. I just want that very clearly stated, that we're effectively giving up, like TLS is being used as infrastructure identity connected to a physical resource, which does that then limit our ability to run webhooks off the platform? Or is this just yet one more thing, and we didn't actually simplify the world, we actually added in just a new option?
I guess where my question in this is how is this different than today, where I use something like Cert Manager to keep certificates updated? And how does this change that, other than I'm not deploying Cert Manager?
You aren't actually getting serving certificates.
Yeah, Cert Manager is for external certs. Not that it can't handle internal certs, but that its design mechanisms are for interacting with the public CA list, which is in and of itself a misnomer, but let's not go there.
Okay, but I mean, I do this today. You publish an internal CA with Cert Manager. It creates certs that are signed by that CA. I mean, the math of the PKI doesn't change, and you can control what kind of usages are embedded into the cert. So I guess what I'm failing to see is, how is this different? How are the certs generated by this different than the certs generated by Cert Manager?
As I understand it, when you generate your serving cert with Cert Manager and it gets signed, you can curl and reference your custom CA, and it can verify the name. As I understand this, the goal is to create a certificate that will be used for serving that will not be verifiable with standard tools.
I wouldn't necessarily characterize that as a goal. It's just the way we were approaching it.
So I think we're we are observing the same problem and approaching it at different angles. Like, we have pods loosely coupled with services. So we don't want to give a pod a TLS certificate for host name for a service, especially not a namespace scope DNS name, especially maybe not even I'm trying to think about how many path segments I would feel comfortable encoding in a DNS name for a server cert. One approach to that is not using the host name that you connect to a service as server authorization. You have some out-of-band mechanism to decide what service account should be backing that. And another approach to this problem, where we say pods are loosely coupled to services, is to go all in, I think. So there's, which David and Clayton were recommending. I don't know what the right answer is, but
I guess where I'm kind of getting hung up here, and I'm sorry to believe, to hammer the point, is, and maybe this is the difference between having a distinct server and client cert versus tying the two together. If I want a service that listens to or that listens on a cert with, the existing mechanisms, the existing, server name based mechanisms. I define a cert manager publishes it, and all my pods serve that same cert. I can't uniquely identify each server based on that cert, but if the server then if each pod then had a unique key that had an identity tied to it, that again, I guess I'm missing why these things being combined are actually easier than what exists today.
What do you mean?
What do you mean by combined?
Yeah, I didn't understand that either.
Well, I guess, and maybe I'm conflating two different things here. From what I'm hearing and what I've read, the idea is that I can get a cert mounted in, I can get a key parent cert mounted into my pod, and that key parent cert can be used both to identify me as a client and identify me as a service. And so that way I can start, I can just fire up and say, okay, I'm listening on TLS, out of the box, which, I think everybody will agree is a good idea. And so, but as a webhook, if I do that with a webhook, and I write a lot of webhooks, so I run into this a lot. If I write a webhook, the API server, and I want to do it over TLS, I have to tell the API server today what cert it is, and that cert has to line up with the service, assuming it's running in cluster. And so if my pod cert doesn't have my service name as a subject alternative name, the API server will reject it. So the solution I'm hearing is to change the rules so that it's identified a different way. And I'm not arguing for or against that, to be honest. I would agree that most of the cert rules are pretty awful. But that said, today, the way I handle that is I generate a cert that's bound to the service name rather than to individual pods. And if I need an identity for the pod, I have a client certificate. And that's one of the reasons to separate those things. So I guess what I'm missing here is why a individual cert mounted into a pod is the best approach to identify the server. That's why I'm missing this.
That was actually a useful summary because it actually raised the question for me, which is, I feel like we're talking about three separate things and each of them has value independently. As a pod, I should be able to assert my identity as the pod without disclosing without giving someone else the ability to impersonate me. That's pod client cert. That's a pretty reasonable thing. We talked about this in the pod identity discussions 4 years ago. I think we all agreed it was something we could eventually see ourselves doing. Do we have the context now to decide to go do it? Probably. Should this pod be able to identify itself when serving as a particular pod on a particular infrastructure in a verifiable way? I think that's also valuable. It's a bit of a different use case, but I think, going back to the discussion about Google running this way, like it's an appeal to authority that I actually would appreciate, which is if you're trying to talk to something that you expect to be a certain infrastructure bit, being able to say, is this a certain piece of infrastructure, and then verifying that has some advantages. Then there's a third use case, and this is where it gets a little complex, which is when that element has both infrastructure and service, like general client needs for identifying itself via a local name, a global name in the DNS and TLS worldview. Does having an infrastructure cert compose well with having another cert that's for a client? SNI certainly allows you to do that these days. There maybe is an argument that most workloads running on Cube do want to have an ability to talk to somebody else and assert who they are. They do want someone else to be able to verify that they're part of the infrastructure. And they do also want to be able to support 0 to N extra certs that tie them to names, which you could maybe argue is, if someone were writing the framework in 5 different languages for running on top of Cube, you look for your service account token, you look for your service account identity that you could use to talk that's better than the token in many respects. And you could also look for a set of your infrastructure serving cert and mix that in via SNI when people want to talk to you as if you're that pod. And the question would be, could we come up with the use cases for each of those that justifies it in a single proposal versus teasing it apart into multiple?
And I guess to add on to that, and I appreciate that summary, my next question then becomes, is Kate's the right place to do it if it can already be done with external systems?
If every like gatekeeper Helm chart needs to depend on the cert manager Helm chart, I would say that it probably deserves to have, we probably deserve to have minimal functionality in KDS.
We established that the first time around with pod identity, which, as we said, in general, Cube believes that tying processes to infrastructure in an identifiable way is within our remit. The question would be, can we do it in a way that that consolidates workloads and makes workloads more secure, makes workloads running on Kubernetes more secure and easier to run by default and better for operations teams? And that last one is the kicker. Is it better for an operations team if we introduce this and it conflicts with Cert Manager? No. If we can make if we could introduce some of these things, make clear recommendations and have conventions, then I would say, yes, that absolutely does fit within the remit of what Kubernetes is trying to do. And specifically this SIG, I think, has asserted it has that goal done right in a way that doesn't create problems. So
creating a client certificate doesn't seem significantly different to me than creating a service account token, right? Like I could see it being similar. You asked to have it injected. We're starting something new. I would make it short from the very beginning. Probably not order of minutes, but short. So people can't make things that can't handle it rotating. But serving seems a bit more of a stretch to me, especially like I think I've heard both that we do and do not want it to have the pod listed as a name.
And okay, please.
I was going to say, ignoring the serving case for a second, with the newer style service account tokens, right? We bind them to the identity of the pod, with an extra field, and we verify that. Are we saying we're not going to do that with these plans?
No, I think they would have to be. I think it would be required that the certificate be tied to a UID and a node UID probably. Like in a sense, this is an assertion that's based on the chain of trust from the node. If the node is compromised, then and we had this, like, I think, Denise, you still got a couple of these docs that go through a lot of the different variations on this, which are effectively the prior art from the SIG.
Yeah, I think in what we are working on internally, we include some extra X509 extensions, custom extensions that have
that makes sense. I guess I was going to ask, I don't know how you would build that out of tree today. I don't know how you would present a certificate to the Kubernetes API server that would have extra validation done on it.
With a custom signer is what we're doing.
No, you can make a certificate, and if you have custom extensions on it, the API server will barf and say, I don't know what to do with that. Right? So that it will work in the sense that it doesn't work, but it doesn't actually accomplish what you want, which is I would like you to have a cert that looks like a service account identity, but also does like pod verification and all the stuff Clayton just said about node verification, right?
Well, and I think there's getting into the use case details. I was going to actually add with the token, even, we have to think about some of those elements as well. I was thinking about the parts of the token and the cert that are similar. Now, the one difference is that the client cert, because it's not disclosed, can be longer lived in many dimensions, like to David's point. And there are advantages, even if it is a little bit more expensive to create. But there isn't at least the ability, and this is what we're discussing, the delegation of the node to generate the cert is ultimately, if you don't trust the node at a particular point of time, everything else is questionable. There is at least the logical constructs in X509 to express that, such as a node CA and the necessary choices there, which has advantages over tokens in an operational way.
Yeah. I don't know. In a large shared cluster, yeah, I think you need more than just a node certificate generally. You also need some guarantee that a pod was scheduled on a particular node versus having like a.
Yeah, that's what I meant. The attestation. Someone has to be able to verify that the worker was scheduled that pod, and the pod's UID belongs to that. And at least we have the mechanisms in the cube that could allow that. For a use case for the serving cert, there are webhooks and aggregated APIs that are a little bit more servicey. There are a number of things around health checks, probes, monitoring, and other kubelet to kubelet or kubelet to other thing integrations that are a little complicated. So the fact that we use like a webhook authenticator on the kubelet works because effectively kubelet is rooted on the entire machine, so we don't worry about it too much. But there's a number of cases where if you want to target a pod, being able to say like, what's the easiest way to make sure that every workload on the cluster has an identity that can be verified for an infrastructure integration, the serving cert that's tied to, very scoped to that pod and that bit of infrastructure has some advantages.
It depends on how short things are, right? I mean, like if you're signing for an IP address, you need it to be a really short cert because we reuse those across the cluster.
Yeah, I mean, I feel the same way about a service. Like if you're handing a key out to a pod, the nice thing about service account tokens is once we delete the pods, those service account tokens are revoked. I guess you maybe get away with that with really short durations, but
Unencrypted.
Why couldn't you
HTTP
tie it
never-
also to like I was gonna say, why couldn't you just tie it to like the UID of the service as well, right? So if you delete the service and you make another one, I guess you would need some kind of extra.
You guys are letting the perfect be the enemy of the good here.
I mean, short-lived certs are important here, right? Like at the end of the day, I've suffered enough with people not doing rotation correctly to just always issue short-lived certs and then just have to suck it up. Like
short-lived certs are great, but we can go with 90-day certificates and we are still better than the vast majority of the web. We want to avoid the part where people assume that certificates last forever, but scoping them to the lifetime of a pod is not unreasonable. Just because we don't currently we speak HTTP across the wire, and getting anything that's better than that is better.
What is the refresh period on the OIDC tokens we issue via the projected volume?
it's configurable. It's like an hour by default, and the kubelet refreshes it with a jitter at like 70%. Mike, correct me on that percent.
Yeah.
So
You can go as low as 10 minutes.
Yeah, they can go as low as 10 minutes before the API refuses to give you a shorter one.
So at a minimum level, there's nothing today that blocks this from being done out of tree. The proposal is about the convention. There's probably an argument that the client cert definitely falls within the remit of the original pod identity proposal. And so I'd like to explore that one. And while there's some arguments and counter arguments, I could absolutely believe that we've got a little bit more context to say whether it's worth it. But we did come up already with questions around verifiability and reliability. On the server cert, was the original thrust of the proposal to dramatically improve serving certs? Because I don't feel at least just based on the discussion, I don't feel that we've identified a clear path there.
I think the expectation was we would just issue a client cert, and then people who feel like using those client certs as server certs and are willing to do the pain of customizing their TLS verification could do so if they wanted.
So the only way to do that is if you actually sign with the usage as a server, right? Like there's a client extended usage and a serving extended usage, and you're talking about signing with both.
Sure,
Well,
yeah.
so I guess if we add a client auth bit and a server auth bit and whatever we choose for the service account identifier, whether that's spiffy or the common name system service account thing that we have. Does it matter if if there's an extra service account, or sorry, if there is an extra server auth bit on that certificate? Is there a downside to that? Because then people who either have SPIFFE libraries for MTLS or are willing to do a little extra work can use this for MTLS within a cluster.
So I might be looking at some old version of the proposal, but I'm pretty sure that it includes adding SANs for pod IP and pod host and every service that the pod matches.
So
and
everything below the red line, like,
Yeah.
needs to be reworked based on the consensus we establish about what we are going to do. So that's all mechanism that is not.
And
That's it.
then in addition to that, right, like, so let's say you even do all that, right? In order to use it for the aggregated API servers and admission webhooks, you will need to change the way those verify servers from the means that we use today, which is the standard, am I talking to the server I expect flow, to alternatively do what's the name for this new thing? I'm not familiar with it. I don't know if it's actually a standard or not.
You don't need to
It is
change
allowed in the
those.
standard.
You can shim those though. With a webhook, you can simply set the cert it expects to be the issuing CA.
The name wouldn't match.
Yeah. So you're right. If we wanted to use these, just the client certs in serving mode for aggregated API servers and webhooks, we would need to teach Cube API server how to trust their identity. And we need to put a configuration point that says, what is the service account identity you expect to be talking to when you talk to this DNS name?
And there's also a little bit of different stuff too, right? Like today, like we have token review for delegating stuff to the API server or other places for tokens, right? We have subject access review for doing the same thing for authorization. There's no certificate review. You can't ask someone else to figure out what a certificate means. It happens locally on the client, right? So the Cube API server, kubelet clients, everything in our infrastructure has literally the same meaning for what a CA bundle means for a client cert, right? It says, okay, O is the group and CN is the name. That's all I understand. That's all I will ever understand, right? If you change that in specifically meaningful ways, like, I mean, you could add like a required extension to cause it to fail verification, sure, I guess. But we don't have a way to delegate this today, right? And that's not great, right? I don't want to go update all the endpoints to understand SPIFFE. I'm not even against SPIFFE. It just worries me because I don't really understand how big of a thing I'm getting into. I don't know if this is another X509 thing on top of X509, and I really don't want that.
It's just
SPIFFE
a
just
convention.
says, yeah, it says X509 is a huge, scary standard. Ignore all that. Your certificate should only contain one URI SAN that asserts an identity in a particular format.
Yeah, and I am unopinionated, or I'm slightly opinionated, but I don't have a strong opinion whether we go with our format versus SPIFFE. Like if I look at the community, it seems like SPIFFE is gaining adoption. We have our own thing in the corner. Is it good long-term to go in the direction of other CNCF projects in the industry? Probably. Is that direction SPIFFE? I don't know. But if I go to KubeCon and look at blog posts, it seems like it's picking up steam. So open to alternatives there.
I'm slightly against SPIFFE simply because trust domains are embedded into SPIFFE, and they are the trust domain is treated as global but is actually local. But I don't want to get into that.
Yeah, absolutely. It seems like.
Oh, go ahead, Mike.
I was just going to say, it seems like we have more fundamental issues than the encoding of this certificate to work through here.
I'm struggling with what this proposal wants to do, right? Like I said before, like in terms of client identity, I can get behind that, right? Like, hey, we want to have a way to have a certificate. That sounds great. Sure, let's do that. But then to say that we also want to use it as a serving certificate, and there's going to have like standard serving certificate fields, that seems different. I wouldn't expect the lifetime of those things to be necessarily the same. I think there's a difference between saying someone remote contacted me and let me see if I recognize them, and I am contacting this other server, let me see if it is responding correctly. And then if we're talking about building a new means to evaluate whether we're communicating with the correct server we expect or not, that seems like a separate and distinct thing. And if we want to do that, I'm not necessarily opposed to that either, but it's not clear that that's what we're building first. Like we could go off and have a separate proposal that doesn't actually issue anything and says, okay, we want to have our aggregated API server be able to authenticate a server using, I'm not familiar with the standard. Is it called the SPIFFE standard?
Yeah.
And that seems like a separate thing. If you want that, we could talk about doing that. Is this proposal trying to do all those things?
I don't think
compose
so.
well. All of these
Yeah.
things turn into something magical if you have all of them together. If you have the ability to act as a client or a server identified by your identity, and the Kubernetes API server understands that as well, then you are able to do all of these things, which is all of these complex things with X509 with a relatively simple magical interface. They compose well because yes, you can add server certificate and client certificate to the same thing. And really server certificates and client certificate identification are actually not that different when you are using mutual TLS. Your application is one application, it talks to other applications, and both of them want to know each other's identity. It is the same concept whether you are a server or a client.
It is the same concept, but the trust domains are different.
The trust domains are not different. The trust domain is your cluster.
I think it's a nomenclature thing. The way you authorize somebody to, I guess, what we would need to do as a signer or approver in the Kube API server to approve a serving certificate is very different than what we would need to do to approve a client certificate.
Yes, when I'm trying to decide whether a particular client should speak to me, it is different than whether I'm trying to decide whether the server I'm speaking to is the server I expect.
I think client certificates are a reasonable place to start. That's a well-scoped, like not right now, but it is a well-scoped, it is potentially well-scoped and easily implementable.
One other thing I wanted to ask, sorry, Mike, is can somebody write a concrete list of things of this that cannot be accomplished out of tree today? Like what are the gaps within what we provide as extension points that you need? That way, if those are just intrinsically good, we can just go write the extension points that way.
I can add that to this doc. The main thing is we can do everything out of tree except teach Kube API server to understand a connection from one of these client certs. And even then we could do that if we were willing to layer Envoy or something in front.
So as Clayton mentioned before, this needs to be teased out into like individual things to deliver. There are a number of items here that I think make sense to include in core Kubernetes. I am definitely biased towards like prioritizing this TLS authentication for APIs, aggregated APIs and webhooks, because I think that is way too hard to do securely today. I think we can discuss whether it would be good to offer client certificates as alternatives to tokens. But yeah, I think the answer to your question is a lot of this can be done today out of tree, which is not necessarily a reason that we should do this stuff out of tree forever, that we should always require the gatekeeper Helm chart to also install cert manager, for example.
So I want to be clear. I don't think like client certs for service accounts or the CA stuff and serving cert stuff for API service and admission webhooks, I don't actually think that should be out of tree long term, mostly because I felt the same pain that you felt, Mike. I have written the code that automates this without using the CSR API, and it's zero fun and added zero value to my day. Just the code I had to write to, as an auth carrying person, to have security. So that wasn't fun. And I think I disagree a little bit with David on this type of stuff, where I do think I lean stronger on the in-tree versus out-of-tree thing. What I was trying to tease out is I want to make sure that if there is a gap that cannot be filled today, but we think it is a valuable gap, just due to like, you can't verify a spiffy identity. And if we think that's valuable, let's just do that. That way, because the reality is, if we added this in 122, actually 123 as an alpha, it would take years for this to roll out in a meaningful way across all providers. So it would be great, just like the PSP proposal will be implementable as a webhook and usable across all sorts of environments. It would be nice if you could, I don't know if Helm charts can optionally install a thing. I don't use Helm very often, but I could imagine you optionally install Cert Manager to get you a bunch of functionality, unless you detect you're at a new enough version and you use the cool new functionality, right? Like,
yeah, I don't know how it works either. I think basically what you're suggesting is we should tease this out even further into the different things we could deliver and then rationalize them individually and experiment out of tree. So
that might make it easier to latch progress as you go along, right? Like the client cert stuff isn't particularly contentious. The spiffy stuff I'm open to for, you know, a way to identify an aggregated API server, but the serving cert aspect of this proposal seems unusual to me. And yeah, I hear like, oh, well, you wouldn't really use it as a serving cert unless somebody else recognized it. And then I see like in the details, like, oh yeah, we're going to put the actual names in so that it can work with legacy connectors as well. And yeah, it's contradictory to read and hear.
While we're having this discussion, how much of this can we get away with?
Yeah, I think some of that is an artifact of Ted and I are coming at this from different places. I think, at least for me, the only thing, like if we decided to do client certs, I would just say, just set the server cert bit as well. Don't necessarily add any other serving cert affordances, but just allow it to be used.
I don't.
No additional sans.
Yeah, I don't think I would start there.
what does that mean though? Like you have no sans but you have a bit set, then why don't set the bit and your custom verifier just doesn't look for the bit?
Actually, I don't know. I think that depends on the structure of TLS.
That is not allowed by the TLS spec. However, you can use out-of-band mechanisms for validating names.
Exactly.
But you are right. We could do it out of tree if we ignore allowed usages of certificates.
I think on the
I'm not sure how that's meaningfully conceptually different than I have a custom like spiffy thing. Like you've assigned the meaning to the fields yourself. And I don't think that's insecure. It's just different.
Yeah, it's true.
Because the TLS spec does actually acknowledge that names are hard and that there are multiple possible conventions for names. The TLS spec is rotting, which is why there are certain sans that we should absolutely never use and not a spiffy san. But it's totally reasonable for a spiffy san to be added. It's just that like clients will take 10 years to catch up to that.
Yeah, it seems like we are maybe digging in a little bit. So what are what are some good next steps? I can recommend teasing this even apart even further into like the different user journeys that we want to enable Clayton had a few. We have a few around webhook hardening, and then you had a few already in the stock. And then
it sounds like a good next step would be write something specifically scoped to the client use case.
Yeah,
just
I agree.
Sounds good. Cool. Is there, we only have 2 minutes left. Do you want to wrap this up? Any closing comments?
Who is you?
Well, it seems like we will have a discussion topic to replace PSP v2 over the next couple meetings. All right. I do not think that we have enough time to go over CI flags and test grid. Does anybody have anything else to say? Otherwise, I move to adjourn. Thanks, everybody. Good discussion.